Okay, I believe we have a stream. Yeah, we have a stream. Okay, welcome back to part 2. This is gonna be a coding session. So we're creating the Polkadot Treasury report. In part 1, we did a little bit of planning. We sourced some data and we did categorization. Now for part 2, we identified some small issues that we want to have a look into. So these might be things where the code is not doing fine, and we have like one little bit less than 2 hours. So this is pretty much ideal to do a little bit of coding and check out is there anything wrong with our code or whatever. So, and I was thinking of, because I've never really explained the code base for anyone, so I'm gonna give a little bit of a tour through the OpenGov monitor code base here. Okay, so you can find this project and let me pull up GitHub real quick here. Zoop. Still getting used to Ubuntu. This is under OpenGov Watch, OpenGov Monitor repository. And you can pull the data from here, you can pull the code from here. So I'm gonna give you a little bit of a tour through the repository, and then we're gonna check out to like go into the practicals. Okay, it's a fairly small project. It's a fairly small project. There is like only I guess like 3 relevant files. Okay, so the first one is the main file, and it's configured to start a server. So if you run it in the basic configuration, it launches a server. You can also launch it with the parameter run, and then it just runs the program through one time. And then what it does is it sets up some like basic config. It pulls in from a credentials file, and it pulls in from the config. And then you configure some limits. So how many referenda it should pull, how many child bounties it should pull. I just set it to very large values. And then what it does is it checks if it should fetch referenda, it fetches them, and if it should fetch child bounties, it fetches them. This is a little bit of old code that I'm still keeping around, but I might remove it. And so what it does is when it checks referenda and when it checks child bounties, it fetches them from a data source, which is subsquare. It transforms them, and then it puts them into a spreadsheet, into a Google spreadsheet. So hi everyone coming in. You may ask questions in chat anytime. So I'm gonna quickly like review with you the process of how it fetches the data, it transforms the data, and then it syncs the data. So what it basically does is it uses Subsquare as a platform. So it uses essentially the same data as if you are visiting polkadot.subsquare.io. It uses the exact same data. So what we see here when we visit that website is we are seeing like all kinds of referenda, and we are seeing this referenda list here. So, and the same calls that are going to the server from Subsquare to get those data, the same API calls are the API calls that we're using in our code repository. So this is our data source where we pull the data from. We use Subsquare as a service, and then the sync basically just uses the Google spreadsheet library to sync the data there. Right, and so then we put the referenda there. Okay, so we're gonna look a little bit into the querying code, and it's not super cleaned up. It has been growing over time, but it should also not be too messy. So let's draw this out. Let's look at this a little bit. So from the signatures that we have like fetch referenda, transform referenda, fetch treasury proposals, fetch child bounties, and then there is a few helper functions. And I would say the most advanced and defined code is fetch referenda. And then in transform referenda, it has a few functions that I defined inline and transform referenda because I'm using them only there. And these are all kinds of helpers that help us interpret the data when we transform it. So fetch referenda should be pretty boring, or like, let's say simple. It just it fetches the referenda into a data frame, and then I think on certain referenda it needs to fetch in details. So the way subsquare works, the subsquare API works, it gives sort of like rough data on each referendum, and it gives you paginated list of referenda. And then for certain referenda, you want to pull in details. So we know, so we know that for certain calls, for certain call indices, we need to pull in details. So we have a list, we have a defined list of calls where we need to pull in further details and information, and then we go through all the updates that we get, all the rows that we get, and for some of them we fetch additional details from the server, from the details JSON, right? So for some referenda, we just the single paginated call is okay, and we get the list and we have all the information that we want. And for some calls, for example, batch calls and XCM palettes, like for them, we need to fetch the details. Okay, so this is how we fetch the data, and then we transform the data. And what we do when we transform the data is, so we got the data from the server, we got a list of rows of referenda from the server. And then we're going to prepare a data frame. So this is a little bit ugly, but it's practical, it has been growing. So what this code here does is it prepares all the columns in the data frame so that we can write them to the spreadsheet. So at the end of the call, what we want to have is a data frame with columns that correspond to our output. So let me pull the resulting sheet up for you so that you know what's happening. So the output that we're producing is this spreadsheet, which is the ID in the form of a hyperlink that has the link to Subsquare, and then the ID. And then we have a title, we have a status, we have the amount of dot, and so on and so on and so on, right? So this is the data that we're actually looking for. And so these lines of code here are actually sort of like preparing those rows. So at the end of our call, we have the title, we have the status, we have the proposal time, and so on. We have the track, we have the votes, and we have the individual components. So this is where we're pulling all of this together. This is where we are making those columns. And then for some of those columns, we have dedicated functions. So for example, when it comes to the amount of dot, to the amount of USD, the proposal is essentially, we have to assume that it is a mixed bag. So there can be USDC, USDT, dot. There could even be other assets that are requested. And there could be a combination of those assets that are requested. And we saw actual proposals that requested a combination of USDT, USDC, and dot. So what we have to do is we have to inspect the whole call. We have to look into the details of the call, and it could be faceted because it could be instructions to another chain. So we have to traverse the whole call. We have to inspect the call, and then sort of count every time some value is being requested to be transferred from the Treasury out. We have to build a bag. So we're having a class that's called a bag, and it's a bag of dot, USDC, USDT, maybe other assets. So first of all, we do a deep inspection into the call. We build a bag, and then once we have that bag and we just split it down into components, then we can ask for the value of the bag. And the value of the bag is, for example, requested in dot equivalent, or it's in USD equivalent. So when we want to have dot equivalent, we need to have the exchange rate from dollars to dot. And the other way, when we want to have the value denominated in USD, we have to basically calculate the value of each individual component in USD, and then we add it together. So this is why we have this value converter. This value converter basically gives us a bag. Where is the bag? Yeah, so we first of all, like, we have this helper column where we create a bag, and that bag is just an object. So we make a column that holds our bag, and then for the columns where we need the actual values, we need the value of the bag at a certain point in time. So this is where the value converter takes the bag and the date, and this could be the proposal time, or it could be latest status change time, and then we tell it to which asset at which point in time we want to convert that back, and that's then the value that we're given. That was quite a bit of work to come up with that thing. Yeah, I would say that's the most relevant thing. So the toughest challenge here is actually to build that bag by doing a deep packet inspection, and this is typically where new issues can arise when the network is evolving and we have new types of proposals coming up that do requests in new ways. Then yeah, we discover new issues that we need to fix. So sometimes the script breaks, and I'm trying to get more defensive in not having it break, but it should also not let pass everything through that is unknown. So yeah, this is always an interesting trade-off. Okay, so this is a rough overview, and then we're syncing all of that stuff. Then we have basically a data frame, and then we're syncing it into a spreadsheet. That part is not interesting, so we're not going through that. So okay, and now we have noted a few issues where we see that we might need to look into that. So, and the first one is Ref 1424. So let's take a look back into the Treasury report, and let's just have a look at what we're actually seeing when we have those. So 1424, what was it? That was like a famous one, 1424. Okay, we need to remove all our filters. For emergency response plans for securing $200,000. So this was actually not affecting any of our. This is actually a zero value proposal, but there was something wrong with the. So I fixed it here. So let's look at the monitoring, which is pulling live data. This gets shown in a weird way, and so I think this is an excellent example, maybe, to look at a few of these details in how the code actually transforms a bag. So yeah, what we get here is none. This is at 0, and then we get none here. So there is like a hiccup in the conversion, let's say. So we're gonna look into this. And so what we get is dot is empty, and USD proposed state is none, and actually this should be shown as 0 in this case. So we're gonna look at subsquare, and I know that I created like a very because there is a lot of exceptions where it's just this one time someone did something weird, and it's not worth like writing the most sophisticated code. Sometimes I just like add exceptions in the code to basically ignore this piece of data. But what we do is at some point in time we want to build a bag from the data, and this is the assets bag that we just discussed. So, and then recently I added this piece of code here where we say this is a known zero value proposal. So we know this proposal is of zero value, and it's maybe too complex to write code. So maybe this could be a good annotation. For some proposals, it would be too troublesome to write the deep packet inspection. So we just set the back to none, right? So this is what happens here, but then apparently we set the back to none, and then apparently the conversion later doesn't like give meaningful values. So we set it to none. Do we return also? Yeah, we return. So what we should do is we build the bag, and then later on we have a conversion, and we can see that when we wanted to build the dot value and the USD proposed date value. So this is the dot value. Native asset. At proposal time value. Then, okay, we ask the value converter to give us something. So something in this function is messing up. So this function is taking a bag, and it's taking the target asset that we want to denominate it, and it wants to have a date. And this is in a certain column. And then we look at that and we calculate the value of the bag at that point in time. So, but something here tells us that if the bag is none, we should just ask if the bag is none. So first of all, let's look what is actually set none, what is it actually doing. Set none sets none to true. And then get total value should, so it returns a float of value none, not a number, which is fine, but it doesn't look pretty in the table. So maybe we should just return 0, or we do that conversion at a later point in time. I think having it as none here would be good, because only when we want to actually present the information, then we should make the decision to show it as 0. So this is maybe something that should go into the if self is none. So we can assume that we have none here. The question is, why do we have only none at certain points and other points are empty? Because this is 0, 0, 0. This is USD last update, and this is empty. This is really ugly. Something is going on here that shouldn't be going on. But this looks like it happens all the time. And we do the same thing for both assets. I'm gonna just look a little bit into the code just quickly to see if we make a big differentiation between the asset kind. So this is dot, or this is dot, or this is USD, and then we get the total value. But if it is none, it returns none. Right, so the question is just, I think I'm gonna just look into the sync where we're actually syncing the data into the spreadsheet. And we should actually have some code there that transforms none values into update worksheet. Maybe we're formatting some parts. Okay, so how do we sync a spreadsheet, a data frame into a spreadsheet? We load the spreadsheet, we open a connection to the spreadsheet, and then we have some formatting going on. Wait, where are we? Preparing to apply updates. Yeah. But formatting requests append field. Yeah, so we're filtering and sorting. So this is basically formatting, and so this is the code that actually adds the data to the sheet. So let's look into this. Yeah, this is what I was expecting when we're filling values. The question is, maybe we should also like sheet df fill. No, it doesn't exist. Yeah, I'm wondering. At some point, we need to we are making a difference where we are where we are preparing the data frame for rendering, and then we are only making it. We're preparing it for certain columns and not for others. So I guess it's in process deltas. Not yet. So it's either before or after. df. So this is the incoming. This is the incoming data frame. And the incoming data frame is getting prepared here. Transform date is not that. Yeah, so this is dot and this is USD proposal time. But the dot and then USD propose time, maybe it's about this. Proposal time, USD proposal time, USD proposal time. I wonder if the value here is, but we're converting the whole column. I'm gonna add a break here. And then I'm just gonna let the program run to this point here. And I'm gonna inspect the data if it's already converted here or not. Okay. So this is gonna run the program now for the first time. And we actually don't need to run all of the code. So I could set the config to only run like 200 and 0 of those. And then we restart the program. Okay, so let's just fetch like the last 200 requests. Yeah, and you see this is what I talked about. It's also fetching some details. Okay, good. Yeah, so this is where we are setting the none value, which might be interesting actually. Let's just let it run for now, because I think what will be interesting for us comes a little bit later. Okay, so now it's syncing the data down. And yeah, and this is where we want to look into it. And why are we actually making a copy? I think there's some AI slop. Okay, so columns. Okay, so I want to look at the df, and I want to look at the df on the location of ID. I think it doesn't work like this, does it? Like this? Is it? How can I query the df on a certain index? Log, but isn't there also ilog? Yeah, this is the emergency response plan. Okay, so we're querying the data, and we have dot latest and we have USD latest. Both for none, it's also none here. So here it's still right. And then what we're doing is we're overwriting those columns. So let's let it run through, and let's check that object again. And now some are converted to none and some are not converted to none. And the thing is, it says dot proposal time and USD proposal time. So this here is actually wrong code. And then we also have USD latest and we have dot latest, and it's actually not just dot, but it's like the native asset. But let's ignore it for now. But let's make an annotation. This should consider, wow. This should consider the native asset of the network, which might also be KZM. Okay, USD proposal time. Tele-ice, tele-nays, tele-turnout, tele-total, proposal time, latest status change, dot latest, USD latest. Okay. So we're gonna transform the data and we're syncing it into the worksheet. Okay, and then let's look at the object one more time. Okay, we have proper none objects here. USDC component, USDT component. This can be 0, but we actually don't know, so this should also be not a number. And then we want to this code is a little bit obscure. We want to filter out none, so I'm gonna ask for some consultation. I got lazy with AI now. I want to filter out none values here to be shown empty. Is empty good or is 0 better? Let's leave it empty. So we're still signaling to the viewer that something is off. So it's a subtle signal, but it's not disturbing as much as if we write the text none into this. Okay, what's the proposal? The proposal is to replace NR and none. Yeah, okay. I would actually think that it makes sense to do it before, but I believe this should work. So let's add a breakpoint here. Let's let it run and see if it gives us the information in a more appealing format. Good. Okay, empty. Good, and we want to have the same for dot component, USDC component, USDT component. The question is, why do we get 0 values here? So this is something that should not happen. This should not happen when we run through the get amount. So something in get amount is wrong. Get amount for right. When we say get amount for bag, we don't want to get 0. We want to get none if the whole bag is none. So let me look at the bag and then get amount and should be 0. Yeah. But so the thing is, if the bag is none, then we should also return none here. So if self none, then return float none. I think this is fair. Yeah, and if, okay, so then I think this should be fine like this. Okay, so let's let it run more time. And then we should get all the non-values pulled through. So yeah, why am I doing this work? The thing is, you're processing data in different stages. First you pull it from the blockchain, then you transform it, and then you put it out. But because it's always messy, you want to have like a lot of clarity on what data is reliable and what not. And so using none as a value gives you more clarity on when there was actually like something wonky happening somewhere in the process, and it helps you pinpoint it much better where you want to look closely for what's going on. Yeah, so yeah, we transformed it to empty values here, and this shows us now, because we see the non-values here, it shows us that we're not transforming this part, latest status change, which means we want to convert this to, and so this means there is a dot component, and there is a USDC component, and there is a USDT component. Let me make a new line here. Okay, I think we're happy about this. So then I'm gonna let this code run one more time. And then we will see if we get the right information, and I think we will get the right information. Okay, let's go ahead. This looks good. We're getting empty values. Okay, so if we let this run now, then we should be able to check the output. We should be able to check the output in the right place. Let me use this link in my other browser. Nope, this is the wrong thing. One 1424. Yeah, it's giving empty rows. Good. Okay, so that is an important fix that gives us more reliable data. And so what we have now is we have these columns empty, and this here empty too. Zoop, zoop, zoop. Good. Okay, so this is one fix, and so I'm gonna commit this for now, and I'm gonna not so not the config, but asset spec subsquare spreadsheet, and we're communicating better handling of non-values. Okay, so this was the first issue. We have this solved now, and then I had some other issues here. So the first one was convert part of .assets to stable coins, right? And so my assumption here is this is a DCA proposal, so this should actually have a value, but we're seeing it as 0 value, and so something is off. So, and what this means is that my deep packet inspection does not properly calculate the value. Right? So there's different ways. It's either given directly by Subsquare. This is when Subsquare does the calculation, then we don't need to go inside. But Subsquare also does not do this because Subsquare would also have to do the packet inspection. So what we want to do is we want to check what is actually going on. So this is a root proposal. Okay, and what root is now doing is it is saying dispatch as the Treasury an XCM transfer to a certain parachain into an account of a certain parachain a certain amount of assets, and the asset is 0 here, which means the local dot amount. Okay, so this is interesting because we're doing an XCM transfer, as the Treasury, which is important. And the Treasury is sending dot to this location. Okay, then let's check what the other ones are doing. This is the patch scheduled after, so it's waiting for some amount of time. And then it is sending a message to the parent chain. This is going to be a hydration in this case. And it is telling hydration to withdraw the dot that was just sent, or some amount, and then buy some execution with the dot and call a certain certain call data, and then whatever it uses for gas, it guesses, and then the rest gets refunded. And deposit asset. Okay, it seems like there is like this operation might yield some assets or so, I don't know. And then we wanna put them in some amount, some account. Okay, and then scheduled after. Okay, I guess we do the same thing again, and we send like different instructions to hydration, and we're waiting. And then utility dispatch as the Treasury. So we're again as the Treasury sending more dot, maybe more dot to a certain account. Okay, so apparently we're sending dot to different accounts. Okay, so this is the call that we are basically looking at here, and for some reason our code in our library is not properly figuring that out. So this is where we go into deep packet inspection now, and we check this out. So first of all, I'm going to show you the code that does the packet inspection here. And that is again here. Okay, so what we're doing is we are having this call data, and we're saying build a bag from the data in that row. Okay, so first of all, we're looking if subscript is attaching this attribute. If subscript is attaching this attribute, it means we have the exact amount, and we don't need to look it up. And what we do then is we just like create a bag with dot, and we fill that bag with dot. So that is not what's going to happen in this case. In this case, it's more complex. Then we're asking if it is a Treasury. Oh, it seems like we're actually getting the information from subscript. Okay, let me quickly add this to my to-do list. Check if we actually can determine the dot value of new bounties. Interesting. Okay. Okay, and then if we don't get the values like hand delivered, then we need to calculate them on our own. And so what we do is we build the bag from the call value. So we say each call has a certain value, and then the call might include subcalls. So it might be batching or including other calls. And then, so we say fill up this bag. This is the call data that you have. And this is the ref ID. I think we do this for debugging purposes. We are handing down the ref ID so that if there is some issue popping up, we can log it out. And the proposal time, I don't know. Okay, so we're looking at the call. Okay, and now this is basically what is happening here is on the root level, we have a batch all call, utility batch all. Okay, so what we're doing here is, let me close this for now. We're gonna look at this in a second. What we're doing is we're checking the call if it has a pre-image. If not, we return. We check if there is like a call nested in a call, and then we're taking the call index. And this is basically asking what is the instruction of the call. We take the call index with what is the actual call and what are the arguments to the call. And then we're going through and we're checking, depending on the call index, we react differently to the call. Right? And so there's all kinds of things on how we're reacting. Yeah, and actually we added this manual exception here. which is fine, but we shouldn't actually do this. We shouldn't actually do this here in the code. We should actually give this a value. So we skipped it here in the past. Okay, so I added code here to actually skip this, but don't want to do this anymore. We want to handle it in a smarter way now. Right, so we have actually, okay, so depending on the call, we handle it differently. And so we have, for example, a list of wrapped proposals, which means it's like there is proposals underneath it. There is like a wrapper that wraps other proposals. And so, for example, utility batch all, which we have in this case, it's a wrapper, right? And so what happens when you encounter a wrapper? Where is it? If it's in wrapped proposals, we're looking exactly at the call index, and depending on the call index, we're interpreting it differently. And so for batch calls, we basically, we unroll them. We roll over them in a loop, and then we say, okay, for each of the subcalls, let's add to the bag here. So, and this is what happens here. So on the top level, we go through a batch, and then we say, okay, we need to build our bag from all the subcalls. And then we go through the subcalls, and this subcall here, the dispatches, this is proposal 1104, right? So we have code here that says dispatches, and when it's a dispatch as, we added like an exception to just ignore it. But I think we should not do this anymore. I think, yeah, we should actually implement this piece of code. So what we're doing here is, if we don't know it, we say, oh, we did not implement it. And for those calls, because we know they're income neutral, because we're just like doing a swap campaign, but this is, we can actually do this in a smarter way, right? So what we want to do is we want to actually now look at the call and see how we can interpret it properly. Okay, so, or this is a rat's nest and we shouldn't do it. I think we should do it. I think we should rather handle it in the future if it's not a good idea, and maybe get more sophisticated. But this deep packet inspection is, to be honest, fairly interesting, and like it teaches you a lot about like how Polkadot works under the hood. So looking into this is always like very, very educational. Okay, so we're looking at a dispatch as call, and it has 2 fields, and the first field is who is the origin of the call, and then the second parameter is what is the call actually, right? So what would be good is in the origin to check if it is actually the treasury that is originating the call. But I would say if it is not, we should, let's say we only count if it is the treasury. If it is not the treasury, let's emit a warning. And then in the future, we can add exceptions if we know it's a certain call, and then not emit the warning. So, but let's check the first call if it is actually coming from the treasury. So I'm gonna remove this exception here. Let me remove this exception here. So we should actually be running into this code path here. And then what we do is I wanna add a breakpoint here, right? So I wanna say pi is free, which is my typical way to do a breakpoint. We don't need to do this. But let me add a breakpoint here, and we're gonna do a call inspection at this point. So I'm letting the program run, and then we need to maybe do a few more calls. So it's like 1104. So if we do like 500 calls, this should be sufficient. Okay, so let's let it run. We're checking the latest 500 calls. And within those latest 500 calls, we have our call 1104. We're gonna inspect the packet and improve the code a little bit. We did not break here. Why did we not break? Are we running into another code path? Call inits. Dispatches. Yeah, we're skipping this. It's weird. Okay, then I'm gonna do something. I'm gonna do something fun, and I'm just gonna say, like, I'm gonna add a debug break. So if rev ID is 1104 pi3, I'm gonna add a breakpoint here, and we're just gonna look at the code while it runs through here. We have a breakpoint here, and then we can figure out why it's not breaking where I'm expecting it to break. Or is the debugger not on? No, the debugger should be on actually. Good. What do we have? Okay, so call index is none. Okay. Call index is 1 AO2. Yeah, which is a rep proposal. So this is basically the batched call, right? So we're going through the batched call now. And then it's a dispatch. Okay. Yeah, so basically we're going through the batch all, and then we're going one layer deeper, and we're going through the first part of this thing. Okay, so, and the first part is this utility dispatches. So we're breaking again. And then because it is, we have some code here for dispatches. Yeah, so we're actually looking at the dispatches. So, which means that this part of the code doesn't even get called anymore, because we were already in this part of the code. So this is a little bit of dead code, which means we can delete it. Should we delete it? Yeah, it's a wrapped call. And we have to add this this piece of code here, dispatched. Okay, the first thing I would like to do is, okay, we can remove this thing here that grabs our code, and I'm adding a breakpoint here. And let it run. And maybe just let me paste what I just cut so that I'm not losing this. So what do we do with this? Okay, I think should be fine. Stablecoin conversion, Starlay, what was this? Fellowship sub Treasury. No, this should be fine. But let me have the breakpoint here, and then we let it run. Okay, we don't want the breakpoint here. Good. This is where we want our breakpoint. Utility dispatches. I added the code at the wrong point. let me jump over this. Okay, now we have a call. Let's check out the call. Okay. So utility batch all, and it has arguments. And the first argument this is batch all. Wait a minute. Why is it batch all when it's in this code path? That doesn't look right. What? Utility dispatch as. This looks dangerous. This shouldn't be like this. This should be inner call. Okay, I'm gonna let this run again because this was weird. This should not happen. Good. Wrong ref ID. But it does not matter, we can still look at it. Okay, so what's our call? We're already looking at the inner call. This is bad, this is too early. This is too early. We need to move this piece of code up. So this is always the inner call. It's always the inner call. No. I see. So at this point it doesn't even matter anymore. But this is not okay. It should not be like this. Okay, let me quickly fix this. So unsafe. Okay, anyways, okay, we would want to break here and not override our call, which we're doing now. Okay, so let's review. What do we want to do? We want to inspect this call here and see if actually money is if the call is dispatched as the treasurer, and if the treasurer wants to move money, then we are interested in looking further into it. Okay, so our call is a dispatch as. Okay, so finally we have the right call. We have a dispatch as, and now we are interested in the arguments. The 0th argument should be that it is signing as the treasury, which is this address, I guess. Let's see if it's, what's our rev idea here? It's the rev ID. Okay, 1501. Let's check if this is also true of 1501. Yeah, it's true for 1501 too. So in this case, No, is it not? Is it not? That looks okay. Okay, so this is the Treasury. So okay, so the network info should contain a Treasury address, and that Treasury address should be given as a parameter, and this has to be called when the subscribe provider gets initialized, and then the Treasury address here, the network info gets initialized with the network. Okay, and then what did we just change? What did we just change? Did we change the subscribe provider? Ah, yeah. Bad? Not correct. Whoops. So we wanna have the network info self.treasury URL, not treasury URL, treasury address be this. And then we should also have the Kusama Treasury address, so Kusama Treasury square. Let's quickly look it up. Kusama.subscan.io. Blockchain. Let's see if we can quickly find this. Yeah, Treasury. Okay, so if I'm correct, this is the address of the Treasury in Kusama self dot Treasury address is oh wait, what was it guessing? It was guessing FF. Interesting. Okay, so okay. Good, so now we can call upon that. And we can say that the self dot network info dot treasury address, which is good. Okay. So when we get a dispatch as, we want to know is the dispatch source. Okay, and we set this as we want to get the args at location 0, and then we want to have the value and system signed. Yeah, so I would say we just wrap it in a try catch block, and if it fails, we give a warning. Okay, so try, we put it here, and then we just go all the way. System signed. Okay, so Yeah, and let's say accept key error, and then we log a warning. So then we say self dot, what's the logger? Are we using the logger here? Yeah, logger. Logger dot, let's say there's a warning. And then what can we return? Okay, we can just return. Fine. Can we call it when it is in the inner scope? Okay, so okay, let's ask if, so then we can do, yeah, log a warning and return, this is fine. And in all the other cases, we can continue to inspect the call. This is fine. So now we, okay, so let's make sure the caller is the Treasury. Okay, and if it is the Treasury, what do we do? Okay, if the call gets dispatched from the Treasury, no, where is it? If the call gets dispatched from the Treasury, okay, then we just want to inspect it, and we just basically assume that it is valid. So then we just push it further down the stack, which means we just need to get the call, and the call is the first parameter and then the value. This looks good. Okay, so this is definitely income neutral. This is income neutral. I just want to see what this is. What's the story here? Hacker's account to the starter account. Okay, so this should be actually an exception that gives us a different result. So what we're gonna do here is, I'm interested in this one, so I'm gonna make a breakpoint for this call. If rev ID equals 546, I'm gonna break here and see what's happening. And for the other ones, I think we can sort of remove this here. And we should be doing good and fine. Let's see. Let's run it. Good. What is our ref ID? Not visible here. 1501. What was that? 1501. Ah, that was the stablecoin conversion, right? So the stablecoin conversion is coming from the Treasury, and then the inner call, what is it? Inner call is a batch. to the XCM palette. Okay, you know what? I'm just gonna let it run. Okay. Yeah, so we're actually getting info unknown proposal type, and this actually should be a warning. So let's make this a warning. And the call index is 6308 XCM palette limited reserve transfer assets. Nice. Okay. So we can, okay, so basically what we did is we inspect the call, we say, it's a dispatch as a treasury. Okay. So we're going to take the inner call because we are acting as we are analyzing it as a treasury. And so it's fine. We're just have to look deeper into the packet. Okay. Now we encounter a new type of call. And so we have to now learn how to inspect that type of call. And that's a reserve transfer asset. And a reserve transfer asset, I guess, is pretty similar to XCM palette send. So we have to say 63. Where is it? 08. And it is an XCM palette limited reserve transfer assets. Okay, and then we have to find the right point in code where we actually look into this. So this is not a known zero value call index. It's also the same with XCM palette send. So this is not zero value then. It's more like, is it wrapped? Is it wrapped? It's not a wrap proposal. Should inspect. It's not a wrap proposal. It's just a proposal we need to look into. Okay, so it's just something we need to look into. Wrapped. I mean, we could call it a wrapped proposal. Okay, let's call it a wrapped proposal. But it's not a wrapped proposal. It's not wrapping another call, so it's just, it's not part of this. It's not part of this. Yeah, it's just we go through the call indices. So elif call index bang bang. So if it's this kind of proposal, whatever. Okay, so effort args. Yeah, but we have to do some kind of packet inspection. So let's just make a breakpoint here. Let's let it run. And there was a syntax error. Let's let it run. Still a syntax error. Huh. Okay, but this here, this is still not fine. We will still have to look at this later. Yeah, okay, so now let's look at the call and what it actually does. I want to look at this here. Call. Okay, limited reserve transfer assets. We have a destination, we have a beneficiary. We don't care about this. And then we have assets. Assets is the stuff we're interested in. And then we have a version 4. I think we still don't have an XCM parser, but let me check what else we have that checks for version 4. Get XCM asset kind. Okay. That's all of it. Yeah, which is fine. Yeah, the thing is, yeah, I don't want to add too much abstraction here. So for now, sometimes I'm just hard coding stuff when I see it the first time, and only as it gets more complex, I'm abstracting away and building more sophisticated structures, because sometimes it can be just a one-off, and you don't have to bother it for like another half year, or a year or 2 years. Okay, so we want to look at the assets. So again, we're gonna try catch it because it's very experimental. It's not what we want to do, but thanks. What we want to have is the value. And this is gonna be like super specific now. So this is gonna be args to value v4. If you're unhappy with this, I invite you to do it better. 0 fun. Wait, where are we? Huh? What's happening? What is happening? Okay, let me just write it out. Args to value v4. Okay. Zero. Fun. We are interested in the fungible part, so fun. Is this? Oh God! Why is it encoded like this? Ah, because it's called fun. You know, fungible. Fun. Fungible. Okay. Now it's a string. Oh, we have a value converter for this. We have a value converter for this. Do we not? Apply Dino. Do we not have a value converter for this? Yeah. We have a value converter for this. Where is it? It is in the network info. Okay, so what we want to have is, so there's the raw value, and then we want to have self network info, apply denomination, raw value network asset. Nice. And so this should be the value. And then what do we do then? We add it to the bag. So that would be bag add asset. Okay. Okay, and then we can catch the exception. please improve the impl for call index. Okay. Return. Maybe let's make it finally. Ah, no. No. Return. Okay, let's let it run until here and see if we're properly extracting the value for a limited reserve transfer assets. And then this is gonna become fun when it gets changed away from dot, which it is once we are moving to hub. Good, I see that we have concurrent views on the stream. Say hi to me if you're a human. Good. So let's check if that is working. Okay, this looks legit. So what is this? This is 1501 with a value of 5 million. Let's see. Let's see. 1501. And 1501, yeah, this has a value of 5 million and 1000 dot. So my guess is the first call is dispatching 5 million. Let's say it is this. Raw. Starts with a B. Yeah, this is this. And then I would guess the second value is the 1000 for our friend who makes the original fungible. Okay, so this is suddenly no longer, but this is, I guess this is the 1000 dot. Good. This is very good. So this means we can add this to our bag. Let's let it run. Ah, okay. And for ref 1104, we're going into a different way of handling the ref. Okay, so for the first call it worked out. I hit run and now it runs through other refs and then it comes to 1104 and here the signature is a little bit different. I guess it was like version 3 or something. So we're gonna improve our implementation a bit. So give me args. And we are still on the XCM reserve assets, but we are on version 3 now. Right? So what we do is we check out the, what's it called? The assets. So we say assets, and this is args to value. So this is how far we go. And then we say if we for in assets, and then we do the thing where we start from here. And we say raw value equals assets, bang. And then if we say, then they say else if, and then let's say it was roughly like this, but let's check it out exactly. So it's value, it's version 3, param 0, it's fun, it's fungible, and it has the same thing. Okay, looks good to me. So this might be everything we need. And then there should be an else here. So, and then the else is, I would say, else. Call not implement, that's fine. Let's raise a key error, then we can catch it here. Whoops. What? Did we pass for everything? Why did we not catch the breakpoint here? Why did we not catch the breakpoint here? Ah, because we didn't go as far. Okay, so looks like we have like some part of the implementation right, and we have to check the output of these here. But this looks like a very good first step. Okay, now let's change the config to go deeper. And let's let everything run again. Okay. So I'm preparing the spreadsheet, and then we can compare if we are properly fetching those XAM transfers. It's always impressive to me when people actually join this call. But it depends, like if you like data processing. Okay, so this was the Starlight drama, and this was, I already forgot it again, 546. 546. Dot from the hacker's account to Starlight's account. Okay, let's see what happens. So we should just ignore this one because it is not coming from the Treasury. So yeah, so this is not the Treasury, this is actually like someone trying to get money. And so because it is not coming from the Treasury, we can ignore this. And this seems to work. So what we can do here is we remove this breakpoint, and then we say, yeah, and then we lock this. Now I have a special facility for just refs that we can ignore, so that we don't like have like excessive warnings, and it's this one here, which is Starlight. And I guess it's a Starlight hack recovery attempt. Yeah. So you see we have multiple recovery attempts that we just say we ignore these ones because they are not relevant for the Polkadot Treasury. This is not a spend from the Polkadot Treasury. Good, and so we can remove some extra code here, and we should be fine. We should be fine. So we can remove this here, and then because everything passed through, let's let it run. And I'm gonna just rerun it again to see how the warnings are flying through. And then I think we might have removed all outstanding issues with the code, and we can sleep well knowing that we are properly scraping the Treasury. Which would be good because in half an hour attempts at governance is starting, and I would like to be at attempts at governance. Okay, unknown proposal type, interesting. XAM palette limited teleport assets. Interesting. Yeah, limited teleport assets would likely be moving assets to another chain. So there's also a call that we should implement. But for now, okay, so for now the run went as planned. So we can compare now, and we can check if these now have a value assigned. Boop, boop, boop. Okay, so the first one is 832. Funding the technical fellowship sub-treasury, and still 0. This is sad. This should not be 0, should it? No, it should not be 0. Okay. Let's see the other ones. 1104. Okay, this has convert part of DOT assets to stable coins, but this has like a weird amount. This does not look right. It should have 5 million. So something is off here, something is wrong. Okay, so we have to figure this one out. Wrong value, showing 0. 457. 457. Also, this is also weird value. 3.4. But 3.4 and then 5,000. Is someone getting 5,000? Maybe, yeah, I guess it's the 5,000 that were sent to be used as fees, maybe? Is this a possibility? 5,000. Okay, looks fine to me. Okay, so this looks like it has a correct value assigned. And then 231. Let's check this one too. 231. No. Whoops. Why is there no details here? 231. So 231, 469 looks plausible. Looks plausible. 231. Hex to decimal. I'm checking this online. Convert. Yeah, 469. Okay, so this looks like it is giving the correct value. So the only ones that I'm confused here is that this is giving the wrong value, I believe, because what was it? 1104. Yeah, this should be 5,000,001, but it's giving a different value. So I would be interested to learn what's going on here. So let me just see what's going on here by saying if ref ID is 1104, pi is free, or ref ID equals 832. And I think maybe one of these. Okay, 832 was not yet implemented. Good. So then this shouldn't concern us, and we still have to implement it. but if for 1104 something is off. Yeah, 832 is unknown. Okay. So we did not stop here. Oh, the breakpoint did not work. Okay, in the meantime, okay. Later on we can also have a look at what's going on with 832. This is a different type of ref, so we will also you can watch live as my system is going down. Okay, so 1104, let's zoom into that one more time and see what's going on. Oops. Yeah. So the value it is giving us here is crash tab. So the value it is giving us here is 5.261 million. I mean, it's possible. So 1104, how much does it say in the ref does it want to take? Ah, this looks like it is the right amount, 5.261. And then 5,000 dot, okay, and 5,000 dot for fees. Okay, so all of these are correct, and we just need to implement this this one. So I'm gonna let this one pass. This one too may pass. We let it run, and so only 832 is still giving an error because it doesn't know the call index yet, which is a limited teleport assets to another chain. Yeah, so let's have that here as a follow-up. Elif call index equals so this is 6309 limited teleport assets. Okay, and then some kind of guess, thank you, for how it looks like, which might actually not be too wrong. Parents, value, assets, fungible. Yeah, this doesn't actually look wrong. we have some code duplication here, but it's pretty close to each other. So let's assume this is fine. And let's just give it a breakpoint here. And we're gonna let it run again and see if this is okay. And then in the meantime, I'm writing a little bit of code to move it there. So we don't risk, okay, because we have get asset kind, we can also write a function that says get asset value, get XAM asset value, and we just move this piece of code there. And then it's just a question of at what point do we hand over the argument. But I guess at that, this is pretty good. Yeah, so we are breaking in here. This is ref 832. Let's see if it is handling it correctly. Looks good. Looks good. Did we add something to the bag? Yeah. Yeah, sounds good. Good. Okay, so the code is correct. Then I'm just gonna avoid code duplication by moving this part here. Moving this part here into a dedicated function, which is called def get XAM asset value assets. For some reason it's a float, and this is actually pretty good. This is actually pretty good. Yeah, we should just wrap it in a try catch. Actually, we should wrap everything in a try catch. Yeah. Okay, let's not do a, yeah, maybe let me just make sure that the try catch is proper. This is good. So let's just return. And we're returning. Okay. Yeah, this looks good. This looks simple. So get assets value. Okay. So then let's use this one. Value is bang. Looks good. And let's do the same thing here. Good. And do we have like a general try catch around this? We do not. Bad. Build back from call value. But we should not have it here. We should actually not have a try catch here. We should have the try catch here. Yeah, so there is a try catch. It's just somewhere else. But I mean, would not be bad to have a try catch around the right call index to happen. So maybe let's have that. And let me remove this. Return. There's another try catch here. Okay, this one is fine. It's not fine. that's not fine. We should have this. We should have whatever. Okay, let's wrap all of this into a try catch. Starting here. Try. Bang. Exception. Cool. Good. This is okay. Let's let it run one more time. And I think then our code produces a very sleek base of updated items. And then we can just mark these ones as zero value proposals. Which I'm gonna do right now, because you don't have to wait for this. Okay. You know, you can crash. If you don't want to run, this is fine. No one is forcing you. This can also go, but this should not go. Ooh. Ooh, what's happening? Amount can only concatenate string, not int into string. So someone was giving a string here. Is type is instance. Amount float. Yeah, let's assert that it is a float. Interesting. What did I do here? Good. Where was I? Ah, yeah. Marking. Okay, let's mark these proposals, because then our job here is done. As the code finishes. Okay, funding the fellowship sub-treasury. This actually has value. So once we update it, we need to make sure that this is hidden from the income statement. 832. 832. Yeah. Okay. So at what point in time do we get a string? This function should not output a string. Oh, but it does. We're not converting it. We're not converting it. So we want to say the raw value. The raw value. And then we say value equals self.network info apply denomination, and then we return that thing here. And that should be good. And then we have a denominated value. Okay. 1104. Stablecoin acquisition campaign. We hide this from the income statement. And then 457. Where is ref 457? Don't. What are we? Why are we not? Ah, we're already hiding this one. Okay. And then 231. 231. Polkadot Treasury USDT acquisition. Hide. Okay. Good, we're happy with this. What's happening here? Why do we have a breakpoint? Looks good to me. Good. No warnings, no errors. Everything is syncing. Future warning. Looks good. Okay, let's check the changes we made. There's an assert, this is good. Network info is having the treasury address. And okay, so the main contribution here was to properly check out XCM teleports and dispatch calls. So call data inspection, properly check dispatch as, and check if dispatches comes from Treasury, and then more significantly actually is inspect XCM transfers, which we did not do before. Config YAML should not go there. Commit. Okay, let me check the to-do. So this is for 1104, and this is for, oops. $1104. This is for 832, and this is for 231. Good. Okay, and we move this one to Notion. And then we have like lots of code changes done, and I need to head off to AG now. But these ones are properly done. And these ones might have to go here. Yeah, I might do this off-chain, but I think what you saw now, if you watched until here, is how do we actually do packet inspection for call data? So how do we do call data packet inspection? Yeah, and you saw some of those intricacies. Like if you ever code and look into the call data that is coming from governance, this is sort of the bread and butter of how you look into it. So I hope there was something useful here for you. If you actually like ever see this, like now or in the future, and you come to this point, let me know, because I'm really interested to know if this is relevant for someone. I hope so. Okay, I hope you're having a good day. Thank you.